Hello and welcome to this presentation on unit testing rebooted. I call it rebooted because I believe we've lost sight of the original intent and purpose of unit testing. And a reboot will allow us to start from the ground up and rethink how we go about unit testing. In this session, I'll present an approach to unit testing that I have fine-tuned and put into practice over the years. This approach to unit testing has been informed and guided by a number of books and team experiences. The approach I present will probably not sit right with some of you. If that is the case, I ask you keep an open mind and stick with it. In this session, I hope to elicit a healthy discussion around unit testing so we can, in fact, reboot it and get it right. So who is this session for? This session is for folks who have been doing unit testing for a couple of years or so. This is not a unit testing getting started. If, however, you are getting started, I suggest you look at these series of videos, but nonetheless, get started. Start writing unit tests first, and then come back to these videos and see if you can extract any more than you did the first time. We won't be looking at code samples in this session, but the next sessions I will be showing you lots of code. This is more like an introduction to the new approach, or an introduction to how or why we have lost our way and why I feel we need to reboot. So in this session, we'll be covering a few of these topics. TDD and unit testing as it was envisioned by some of the industry experts. In particular, Kent Beck. What some industry experts say in this section, I'll be talking about what Kent Beck and Martin Fowler have to say about some of the state of unit testing, if you will, in the industry. Then I introduce this approach. It's not a new concept, but I'm going to introduce this approach of testing from the outside in, and also introduce various test categories that I have devised over the years to help with understanding the kinds of unit tests you need to write. In the next sessions, we'll be looking at the taxonomy of test doubles. Now, mocks are test doubles as well. So mocks are a category of test doubles. I'll be introducing to you a bunch of other test doubles and when and how, what they are and when and how you should be using them. In particular, I'll be introducing to you test spies and test mediators that are a replacement for mocks. That's another video. And the final video would be unit testing best practices. Now, they won't be released in any particular order. I will probably release the test spies and mediators video next, since I think there'll be a burning question in a lot of people's minds after watching this video as to how they would go about doing what mocks allow for without using mocks. Right from the get-go, we have a semantic diffusion on what is a unit. If you were to ask 50 people in a room what a unit is, you'll get probably 20 different answers. In some people's mind, a unit, or the thing that we are trying to test, this unit, is a class. In other people's mind, it's a method. So when you write a unit test for a class, so you must write a unit test for every class in the system. And that is unit testing. In some people's minds, writing a unit test for every method of every class in the system is unit testing, including, in some cases, even private methods. If you don't test private methods directly, you're not doing unit testing. Of course, along with the idea of that a unit is a class or a unit is a method, you have these other additional do's and don'ts, or musts and must nots, which is, it is not a unit test if it, talks to your database. It is not a unit test if it's not in memory, and all these other constraints. I've never been a big believer of some of these things, and certainly I didn't find them to be useful, these ideas or constraints. And then there are people in the industry who say unit testing, the unit of unit testing is a unit of work. And then that starts another discussion as to what is a unit of work. I found these two quotes from two people from the unit testing world. One is Roy Osheroff. Roy Osheroff has written a book called The Art of Unit Testing. It's a thin book. It's kind of like Ken Beck's test-driven development book. It's not a whole lot of meat in there. I did find it interesting in some areas. And in particular, I found something interesting in that book, which was the naming convention for test methods, which I have employed in my unit testing and modified it slightly because of what Visual Studio does in the UI that it provides for unit testing. But nonetheless, Roy Osheroff also believes that when you do unit testing, you should be testing a unit of work, and he defines it as such. A unit of work is any functional scenario in the system that contains logic. It can be as short as a function, or it can span multiple classes and functions, and it provides internal or business value to the system under test. So for those of you who are not familiar with the word functional requirements are same as business requirements. By business requirements, I don't mean it's a business system. I just mean the requirements of the system. So functional requirements are requirements of the system. Functional scenarios are then the scenarios or use cases within the requirement. So each requirement could have multiple use cases or scenarios. So a unit of work is essentially testing the functional scenario. It can be as short as a function, or it can span multiple classes or functions. Kent Beck says this in his book. Unit tests focus on functional requirements and scenarios. So now, even though Kent Beck doesn't specify unit of work, he's essentially saying the same thing. He's saying that unit tests focus on functional requirements and scenarios. So both of these people are basically saying the same thing. I'll stick to the unit of work metaphor. So if we believe that a unit test is to be testing a unit of work and not necessarily a class or a method, and a unit of work can span multiple classes and methods, why are we doing the unit testing? What's the point or purpose of unit testing? And I'm bringing these up because I think these are the two areas that if we could stay focused on these two parts, which is what is the unit test and why are we doing it and what are the benefits of it, I think that'll help us understand how to approach unit testing. So in my mind, the purpose of unit testing is there are two big purposes. The first one is to ensure an application fulfills the business and quality requirements for which it was designed. And the benefit from that is that you get the confidence to deploy an application to production. If you can ensure that the application fulfills the business and quality requirements for which it was designed, then you should have the confidence to deploy the application to production. The second is, and this comes by way of building up a suite of tests, you now have a suite of regression tests over a period of time. And the regression tests give you the confidence to refactor. So you can go in and refactor your system without the fear of having to break something that was already working in the past. If you're working for a customer or in a company and somebody's paying you to build software, including the unit tests, then this is the value the business or the customer gets for investing the time, money, and effort in unit testing. So I think these two are important things, and if we keep these, in sight, we should be able to perform our unit testing endeavors without too much of a problem. Now, before we move on, let's just do a level set on what is it meant by refactoring. I know I've talked to multiple people within my teams and across companies and past jobs as well. And refactoring, as simple as it may seem to some people, is sort of misunderstood. So for this conversation, I want to just level set on what refactoring really means. And this comes from Martin Fowler's book on refactoring. Refactoring is a disciplined technique for restructuring an existing body of code, altering its internal structure without changing its external behavior. In other words, when you're refactoring, you are not changing the existing behavior of the system. You're simply changing the code or the internal structure. You could redesign the entire application, but if you are not changing any behavior, you're refactoring. Now, some people think that if a business requirement, let's say a requirement has changed, so let's say you need to add another parameter. Well, that's not a refactor, that's a new requirement. The requirement has changed to the point where it requires you to modify method signatures to add a new parameter and so on. So that doesn't come under the refactoring umbrella, that comes under the new requirement or modified requirement umbrella. When I say refactoring here, I mean simply that you are changing the internal structure of the system without changing the external behavior. Now, over the years, I have a bunch of books, probably a dozen or so books on the software. These are probably the seminal books on software programming, such as and I'm just looking at the list here, the Design Patterns book by the Gang of Four, then the Framework Design Guidelines, which is the .NET Framework Design Guidelines, Code Complete by Steve McConnell, Enterprise Patterns of Enterprise Application Architecture by Martin Fowler, The Pragmatic Programmer by Andrew Hunt, Refactoring to Patterns by Karabsky, Growing Object-Oriented Software by Steve Freeman, Clean Code by Bob Martin, or Dr. Bob, Uncle Bob, I mean, Test-Driven Development by Ken Beck, and so on. Every year I read these books. Sometimes I'll just skim through them, sometimes I'll just read certain chapters more deliberately, maybe either gain some new insight or remind myself of some insight I should have kept in my mind. Last year, 2014, I was reading Ken Beck's book on test-driven development. Now, I've had Ken Beck's book for since 2013, and it's not the best read. I don't think it's a well-written book. It's a pretty tedious read, in fact. A lot of insight, though. So there's a lot of value there, but you kind of have to extract it from the book and really try and understand what it is that he's saying, and he takes a long time to say it. Nonetheless, it's a well-known book, and Kent Beck, of course, is a well-known person in the industry, someone who introduced TDD to the software world. And I was reading this book, and I started to get a certain insight. Gradually, sort of a light bulb went off, and I started to take certain notes while I was reading the book. And I found that without him using explicit words like this is what he's saying. And these bullet points here are not something, you're not going to find a page in his book that says this, but I've extracted this and reworded some of the ways he's saying it into my own words. He says refactoring shouldn't break tests. Now keep in mind what refactoring is. Refactoring is internal structure, change of this code's internal structure, not the requirements. So if you've written a bunch of tests, you're writing tests for functional requirements and scenarios. If those functional requirements and scenarios have not changed, then refactoring should not break tests. And this makes sense. For most of us, I'm sure this makes a lot of sense. Refactoring doesn't warrant writing new tests. So again, same thing. Just because you're changing the internal structure doesn't mean you should be writing new tests. You're writing tests based on functional requirements and scenarios. Those have not changed. Refactoring may introduce new classes, but these classes are not to be tested. So this is, I think, where people start to feel a bit uneasy, because you can't imagine, if you're doing refactoring using mocking, you can't imagine doing any of these three bullets, to be honest, to any degree, without breaking these ideas. In other words, if you're using mocking, there could be some refactorings you can do without breaking tests, but you can't say blindly that no matter what the refactoring is, it shouldn't break tests. Now, I've not been a believer in mocking. Something has always not sat right with me with mocking. So maybe I'm biased, and I thought I was biased for many years. I thought that was just the way it is. I'm just never going to be able to understand why people do mocking, and I just did unit testing slightly differently. And I'll talk about mocking in the next slide. Adding a new class is not a signal for adding a new test. So again, the same idea, right, from the previous one. If refactoring may introduce new classes, these classes are not to be tested. The same as adding a new class is not a signal for adding new tests. Test cases and tests should pass no matter what the design ends up being. Now this goes back to Ken Beck's idea or style of TDD, which is also misunderstood by the industry, I think. People talk about red, green, refactor, and they give you all these stipulations and supposed guidelines for how you're supposed to do it. Kent's been pretty clear in the way he does, at least in his book, the way he's introducing test-driven development. And it goes something like this. You have a functional requirement, and this functional requirement has various scenarios. So let's say this one functional requirement has 10 scenarios that you need to test. So you write a bunch of tests, and these tests will not work initially because you have nothing there. There's no real implementation. So you start implementing this requirement, and he says implement it as simply as possible. Now I'm translating that to mean let's just implement this requirement in one class's one method. And the reason I translate that is because he makes it very clear, don't do any design at this point. The aim is not to start to design. The aim is to just get this thing to work. So to keep it simple, create a new class, give it a method, give it the parameters that this feature will require, this functional requirement would require, and implement it all in this one method, one monolithic method. Get it to work. As simply as possible, just get it to work. Don't worry about design. And so, of course, in his mind, TDD is not just test-driven design, it's test-driven development. What you are designing in some ways is the API. And that's sort of his driver. He likes to see it from the user's perspective. If I were to implement a feature that had this, I would like to interact with this class in this fashion. So he's designing that API, if you will, but not the rest of the stuff. He's not decomposing everything else, all the other classes, if you will. So the API has been designed, the method signature, and then the entire implementation is in this one method. After you're done with all that and it's all working and you got a green, so you've gone from red to green and everything is working, all the scenarios are passing, he says that's when you start to refactor. Now, of course, refactoring is two-pronged. One is you're refactoring the test methods themselves, but you're also refactoring your implementation. And he's very explicit. He says these are two completely different functions. While you're trying to get something to work, you can't be designing and should not be designing. You should leave the designing effort to be done later on, but the unit tests have your back. So that's when he's talking about this. Refactoring shouldn't break tests. So if you're refactoring and you're redesigning, you're re-implementing, changing the internal structure, these tests that were working before should not break. And you take it in baby steps and do it. In his mind, it's all small steps. But at the end of the day, you have completely changed the internal structure or design of your system, and the tests have not broken. And that's what the last bullet point is really trying to say. DHH, David Heinemeier Hansson. He's the creator of Rails, the MVC framework in Ruby, so-called Ruby on Rails. Last year, he wrote a blog post called TDD is Dead, Long Live Testing. And that blog post sent shockwaves in the industry, in the Ruby community, as well as just generally around the software industry. And certainly piqued Ken Beck's and Martin Fowler's interest as well. A few months after that blog post, DHH is on a Google Hangout with Martin Fowler and Ken Beck, basically having a discussion. It's not a very orderly discussion. It's not no specific agenda. A lot of meandering as usual. It's a pretty long, drawn-out session. I think there's 5, 6, or 7 sessions. Nonetheless, in this session, DHH brings up this issue he has with mocking and all the problems mocking comes with. And to that, Ken Beck has this to say: do I mock absolutely everything? My personal practice is that I mock almost nothing. I just don't go very far down the mock path. I've heard people say, I use TDD and now I can't refactor anything. When I look at their tests, I see that their tests are completely coupled to the implementation because of mocks. That's too high a price to pay. That's not a trade-off I'm willing to make. And then Martin Fowler has this to say to the same question: amongst those doing TDD or unit testing, there seems to be a strong desire for isolation and mocking. It's important to point out here that there is nothing within the idea of how you do either TDD or unit testing that says you have to have that kind of isolation. Our style of unit testing, we don't bother about isolation, and it's working very well for us. Thank you very much. I'm with Kent. I hardly ever use mocks. So there's two industry well-knowns, Kent Beck, who wrote the book on TDD, and Martin Fowler on refactoring and has given many talks on unit testing, to say that they don't use mocking or mocks. Kent says, I hardly ever use mocks. Martin says, we don't bother about isolation. So what's going on here? So let's look at an example of mocking. This mocking, the code here is arranged in the AAA style, which is the arrange, act, and assert. And in the arrange, you see all this arrangement that has to be done. In the act, you see that we are essentially testing this unit of work, receive, and on the accounts payable class. And then there's two assertions here. What you should notice right off the bat is that there's a bunch of other classes, like the digital signature, the invoice, which is mocked. Then there's a money that has to be set up for the invoice, and a signature has to be set up for the invoice. Then there's another mock, the signature verifier. And the signature verifier's method, verify, is being mocked as well to return a false. Then there's an invoice repository mock as well. And then finally, the accounts payable class gets instantiated, passing in the signature verifier and the invoice repository. So you're seeing all of the dependencies here, and this is where I have the first problem with mocking, which is, why would I want to know the dependencies? If in my production code, I'm being careful to decouple my classes in such a way that dependencies are not known, or I'm not kind of fixed on a certain dependency, why would I want my unit tests to be aware of these dependencies? Because that is preventing me from refactoring. If I were to redesign my system, I can't do that because stuff is going to break in my unit tests. The other problem I have with mocking is slightly deeper than just the knowing the dependencies, and that is also knowing the methods, and there's their method signatures and the parameters in that sense that this method will require, and the return type. Why would I want to know when I'm testing accounts payable that there is some class 2-3 layers removed from this class downstream from here as a dependency or collaborator that has a method called verify on it that needs to return a bool true false? Why would I know that? I mean, I honestly, in my unit testing style or my design of systems, I don't want to know these things. When I'm working with class A, I really don't want to know its dependencies and how they work, and which one of those dependencies is doing what function for me for this class. And then if you look at the assertions here, you're going down to another method on the invoice repository class to ensure or assert that the insert method was not called, passing in the invoice. I think this is, now people do say this is over specification, but nonetheless, this is how people are doing mocking. At least anywhere I've seen people using mocking, this is what I see. To a larger or lesser degree, the idea is the same. This is what they do with mocking. Now, that's not to say that mocking does not have a purpose, or the mocks are trying to solve a certain purpose. And as people say, mocks assert behavior. And if that is a requirement, which I believe in some cases it is, or in a lot of cases, asserting behavior is important. I don't think mocks are the way to go. Now, mocks are test doubles. There's a bunch of test doubles I'll introduce to you in the next video or in another video. And asserting behavior using spies in conjunction with test mediators is another way to assert behavior. Now, test mediators is a pattern that I have been using, so it's not something well known. They're not mediators, the pattern that's available, that's discussed in the Goff book. This is another pattern called test mediators. And I'll talk about these in another video, specifically this idea of using test mediators and spies to do behavior assertion. But that's all I'm going to leave at that. So it's not to say that mocking is not required or they're useless in that sense. They do solve a problem, or the need to solve that problem does exist. It's the means to how mocks solve the problem versus how spies and test mediators solve the problem. That's the problem I have. There's the means to the end. Now, going back to how Ken Beck and even in Steve Freeman in the Growing Object-Oriented Software book, they talk about this idea of unit testing, or this approach to unit testing. If you remember the discussion of unit of work, where a unit of work is testing a functional scenario. Imagine typically when you're testing class A, and class A has these dependencies or collaborators, and then B has a dependency of E, C has a dependency of F, B also depends on G and H, and so on. So the arrows are showing the dependencies. If you're testing class A, you would sort of draw the seam right here. And you say, I want to make sure I mock B, C, and D, which means now you know about B, C, and D. And when you test B, you want to make sure you mock E, G, and H, and so on. So you're always mocking all the dependencies in this sort of the typical, a unit is a class style of unit testing, which is, I think, the most prominent or dominant way of unit testing. In the way Ken Beck sees unit testing, and he says that in his book, where he calls them shared fixtures, where databases and other things are fixtures or shared fixtures. And if he has to do any mocking, what he does is he just draws the seam over here. So if he's testing class A, he's not mocking B, C, and D, and E, and F. He's only mocking those classes that are, in this case, let's say, talking to a database, talking to an external service, talking to the file system, sending off emails, that sort of thing. So rather than mock everything, he only mocks some classes that do this kind of work. Now, depending on your system, you may or may not have these kinds of classes at all, or you have a whole lot more, like message queues and caches and all kinds of other classes that interact with, that leave your system. I call these the leaf nodes. So these are your leaf nodes of your system. And at some point, something has to touch the real world. Something has to actually do some work. And so if you draw the seam here, while you're doing your testing, you're not unnecessarily mocking all these dependencies. And in fact, in some cases, you may not mock any of your dependencies. I mean, not all of these. For example, in my style of unit testing, I don't mock the class that talks to my database. In most business systems, databases are extremely important. They perform a lot of work, and trying to test something without the database doesn't make sense. So when I do my testing, my unit testing, of course, in this case, the unit is a unit of work, I include this class. So my data manager would be included in the unit tests. In other words, if I'm testing class A that is performing a unit of work, and there are 10 scenarios to that unit of work, functional requirement or functional scenarios, then this class will be in play. I will actually use the real class that talks to the real database with the real store procs and so on. Now, A lot of people have this beef about that's not a unit test, that's an integration test, and they come up with all these reasons for why you should and shouldn't do it. Martin Fowler in, I think it was one of his talks, or maybe it was a blog post, I forget now. He makes it very clear about what he thinks a unit test should be. It should be automated. That's it. Whether it talks to a database or not is irrelevant. Now, of course, if it takes hours to run, then you're going to have a problem with that. He says that then people won't run the test. But if it takes minutes, tens of minutes, it's fine if that's what it is. Depending on how large your system is, the unit test can take a long time. And I've had systems like that, and we have used the database for unit testing, and I think a long time is relative. You don't have to run all the tests each time, but certainly when you do run all the tests on your CI build server, if it takes 10 minutes, okay, it takes 10 minutes. You do have to be cognizant of how fast unit tests are running and not let unit tests take unnecessarily long periods of time, which means you need to be optimized. But then you need to be optimized for production code as well. So I think they go hand in hand. If you understand this idea of drawing the seams at these layers or classes that are reaching out to the real world, then we can move on to the categories of unit tests. So the first category is the acceptance test. And this is what I call outside in. You're working away from the outside. And outside meaning the business systems requirements. So the functional requirements. You're testing your functional requirements. That's kind of like what Ken Beck was saying. That's also what Steve Freeman says in the growing object-oriented software paradigm. And to some extent, Martin Fowler is saying the same thing. You're testing the entire system from, in my case, is the domain facade. So if there's a UI involved, that's not part of the deal. I'm not testing the UI in these tests. I'm testing the sort of business system part, which is, for me, is the domain facade in. So in other words, if this is the UI would be in front of the domain facade. This is the domain facade and the entire system behind it. The UI talks to the domain facade, so it doesn't know about any of the other classes. And so I'm not talking about the UI. I'm talking about just the domain facade and the entire business system here. That's not to say the UI should not be tested. It should be tested. But for this conversation, I'm not talking about the UI. Now, if you have web API controllers or WCF contract, you can test those separately. Acceptance tests are testing the domain facade. So testing the entire system from the domain facade on in, while using test doubles for very few classes. Again, these are the fixtures, third parties, email service, etc. And when you're doing acceptance tests, you're limiting the test doubles to just the bare minimum. So for example, over here, in the way I would do the test of this system, if it talked to these different kinds of things, as an acceptance test, I would not use a test double for my database. I would probably use a test double for this service, depending on the availability of the service. If the service is always going to be available, I don't mind testing against it. But if it is going to be flaky, I would use a test double for that. What kind of test double? We'll talk about that in the next sessions. Would I use a test double for the file system? Well, that depends on the function, of course. If all it's doing is talking to a file system and that's what it's going to be doing, then no. I would certainly abstract out the root path, if you will. So in my systems, if I'm talking to a file system, there's always this root path that is somehow provided to the class, and then that class is always working with relative paths. So if you're storing files or retrieving files from a certain place, it's always from a root folder on down. So there'll be an abstraction in the form of who's going to tell it the root path to work with. But from that point forward, it works physically with the real file system. I will have a class that, I guess, abstracts me from the .NET classes, the IO classes, but there will be a class there. that does the abstraction. So in case I do need to swap it out, or maybe tomorrow I go from a local file system to Azure Blob Storage, then I won't have to redesign the system. But that's again, if I think that's what's going to happen, I don't start off from the scratch like that. Email is probably another class that I would use a test double for, because certainly you don't want emails being sent out every time you run a test, and I'm not sure who the email is going to go to. So emails are another class that I would very likely use test doubles for. So external services, test double. Email, test double. File system, probably not. Database, most likely not. I mean, I don't actually do that, so I'm just saying most likely. In my mind, it's actually never. So that's what an acceptance test is. Imagine these classes to be the same sort of thing from the previous slide, but I have some class that has a few collaborators or dependencies, and then each of these has their own dependencies. And so on. Let's say this one was your database, data manager, and let's say this one is doing the email. I don't need to say this is the database. All right. So when you do an acceptance test, let me also draw the legend for that. See, here's an acceptance test. Sorry, that's the color of an acceptance test. When you do your acceptance test, you would have covered these classes. So let's say that's 1, 2, and so on. So you've practically covered, you should have obviously covered all of your classes in your acceptance test if you're doing your acceptance tests correctly. All right, now we're going to leave the emailing guy, because I've told you I don't normally use that class in my acceptance test. So that's one example of a class that's not actually been covered. Now, the moment you decide to use a test double for a class, when you do your acceptance test, you must have some other test for that class. And here's where I introduce the other categories of tests. So we have another category called a class test. I'll explain to you what that is. Let me draw out the legend for it. So that's yellow. Class tests. So do you write a class test for every class in the system? And I'm calling it out specifically as class test, so there's no semantic diffusion on whether it's a unit and what a unit is. This is a class test. So if it's a class test, it's testing a class. When you decide to test a class, do you test all classes? No. You decide to test a class if that class is either critical or complex, or both. If it's doing something that's critical to the system, then you may decide if you want to write a class test for it. If it's complex and you feel like, you know what, I just want to have a bunch of tests for that class because it's doing complex enough work that warrants me writing a class test for it. So maybe this is the one class you want to write a class test for. So you decide to write a class test for it. It's a choice you make. Typically the guiding factor for me is it critical to the system? Is it complex? Is it doing a lot of, let's say, algorithms that you really don't want to rely on the acceptance test to do the testing for you? And maybe you want to have a suite of tests that allow you to refactor it in the future, because maybe you can optimize it or whatever. It's a choice you make. Then let's talk about the class integration tests. Class integration tests are similar to class tests. I'm trying to pick a color here. So let's say this is a class integration test. I want to say tests. So this emailing class, because you have used a test double in your acceptance tests, you have to write one of the other kinds of tests for it. Now this class is the test for this class would be a class integration test only because of the nature of the class. In other words, it's a class test, but the class is sending off emails, so it's an integration test of sorts. So I call these class integration tests. So any class that's reaching out into the real world or is a leaf node of your system, and you have decided to use a test double for your acceptance tests for whatever reason, then you must have either a class or a class integration test for that class. So that's not a choice at that point. So the fact that I wrote a class test for this class was a choice. The class integration test in this case was not a choice. I mean, this class would require a class test or a class integration test, but that was not a choice because in my acceptance test, I did not use this class. I used a test double. So because I used a test double, I have to write a class integration test for this. Now my data manager, out of choice, I might decide to write a class integration test for this class. Why is it a class integration test? Because again, this class, the nature of this class is such that it's talking to the database. So it's an integration test in that sense. So I frequently decide to write class integration tests for my data managers in addition to the acceptance test that might happen. So even though the acceptance test is covering this class, and I'm not talking about 100% coverage and stuff, I think we'll talk about code coverage in a later session. At this point, I'm keeping it clear of code coverage, but just know that the acceptance test will cover a huge amount of code, right? They'll have a huge amount of code coverage, probably in the order of maybe 90% or so, 85-90%, and that really lets you know what areas need to be covered, what areas shouldn't, and maybe you've done some gold plating. You've got a bunch of conditional statements or scenarios you're expecting, say in this class here, that are never being covered, and you might decide, there's too much of gold plating. Right at this point in time, our business system does not have that need, so let's take it out. So therefore, this class gets completely covered just because you've removed the gold plating. A composite test is similar to something as all of the other tests are a choice you make. So the acceptance tests are the only tests you actually write. You start with writing acceptance tests, and then you look at what's happening within your code coverage, and let code coverage guide you into deciding, in some cases, whether it's gold plating or the class actually needs tests. And of course, when you make a choice for class tests or class integration tests, and the next one, the composite test, is a choice you make based on whether the class is complex or critical, that important enough or complex or both, and you decide to write tests for that. The composite test is nothing but sort of the combination. It could be that, and let's pretend this class here is not your domain facade or anything. Oh, let me change the color. This class is not the domain facade, but it's somewhere internal to your system, and you decided that you want to test this class as a composite test, and you're happy to use the collaborators of this class. Okay, let's say there's these three collaborators here for this class. You're happy to test them together. So for you, that's a composite test. Again, it's a choice you made. For whatever reason, the nature of the beast is such that this class, testing it by itself has no value, because the unit of work it's performing is not by itself. The unit of work that you need to test, that you would like to test, is in collaboration with these other classes. And so you decide to write, let me write the legend here, a composite test for those classes that work in conjunction or in collaboration with other classes. So that's the composite test. Moving on to the next slide here. We have the end-to-end integration test and the edge case test. Now, if you look at the acceptance test and the class test, you might find that maybe there's a class here And let me change the color again. I'm running out of colors that might make any difference. Maybe this class here has got a few edge cases, some areas that are not being covered. And they could be not being covered for many reasons. There could be some upstream validations that prevent bad data reaching this class here. And so you can never exercise that scenario from acceptance tests because of the class before it that prevents the bad data reaching it. And so you can't exercise those scenarios here in this class. So in those cases, you would have an edge case class test. So these are edge cases. And of course, edge cases could be scattered across multiple classes. If that is very unlikely, there's just a few classes that have that those edge cases then that need to be tested separately. So then you decide to write an edge case class test for those classes that have those edge cases that the acceptance test does not cover. And that takes care of the edge case class tests. Finally, we are left with the end-to-end integration test, or what some people call system tests, or there's different names to it for it. But in this case, I'm talking about not the UI tests, but I'm talking about your web API controllers or your WCF contracts, where you're not testing the business part, the functional requirements. You're testing the integration between controllers and your domain side of things. So if the domain side throws an exception, you want to make sure that the controller is converting that exception into the right protocol. In REST, it could be a 404 or 401, whatever the case may be. In SOAP, it could be something else, a SOAP fault, and so on. You want to make sure that those kinds of things are actually working. These are tests that essentially on your CI build server, you would deploy your web application, your API application, and then your test would execute using actual HTTP. So making HTTP calls out to your web application to test some of those features. So these are tests that, of course, will run quite a bit slower, but you decide to run them because that's what you want to do. And those are the the end-to-end integration tests. They test the HTTP endpoints, they test things like routing and ensure that certain bindings work, as well as translations, if you will, from exceptions to protocol-related things, HTTP protocol-related things, and so on. So that brings us to the end of this session on unit testing rebooted. I hope this has been enlightening for some of you, and is probably encouraging some of you to write comments or thumbs up or thumbs down, as the case may be. I look forward to, as I said, starting a discussion on a positive, constructive discussion on are we doing unit testing correctly and how should we be doing unit testing. And I hope you're looking forward to the next parts, the next sessions. There's 3 or 4 of them, and I'll try and get them done as soon as possible. Thank you.